Hello everyone, this is Neelam Sondhya. I am a software engineering student in International Institute of Professional Studies DVV Indore. This is my 11th video. This is my 11th video on logistic. This is my 11th video on logistic regression and patient regression in Python. Okay. So, what is logistic regression and Poisson regression? And powerful static method used for predicting binary outcomes and count data respectively. They are widely employed in various fields including finance, marketing and healthcare. This presentation will guide us through the performance these regression using Python, covering the core components, implementing data and essential considerations. So first one is logistic regression, understanding the fundamentals. So basically, what is logistic regression? Logistic regression is supervised learning technique used for predicting binary outcomes. This is a logistic learning this is supervised learning technique used for binary outcomes such as whether a customer is purchase a product or not. Means this is assume that if it purchase then what, if does not purchase then what. This is a linear model that uses a sigmoid function to transform the linear combination of dependent variables into probability between 0 and 1. The core principle lies in estimating the probability of an event occurring based on the input features. There, we will go through key points of logistic regression and application. So, logistic regression relies on several key components. First one is independent variable. These are the features used to predict the outcomes. Okay, coefficients. These represent the weight of influence of each dependent variable on the outcome. Means coefficient, these are the coefficient of dependent variables. These represent the weight of influence of each independent variable on outcomes. Sigmoid function, this is the new term for us. This function transforms the linear combination of independent variable and coefficient into a probability. Their solve value. What is their solve value? This value determines the classification boundary between two possible outcomes. Okay, what are the applications of logistic regression? So, logistic regression find applications in various domains, including marketing. Means how does this work? How does it work in marketing? Predicting customer churn or respond to marketing campaigns. Finance, assessing credit risk or predicting stock prices. Healthcare, diagnostic disease or predicting patient outcomes. Okay, this is all. This is the we go through what is logistic regression, key points and application. Now, building a logistic regression model in Python. How we build a logistic Python model? So Python explicit learn library provide a comprehensive framework for building and evaluating machine learning. The Python libraries provide us the framework of building and evaluating the machine models, including logistic regression. This process typically involving 7 key points. First one is import libraries. Begin begin with importing necessary libraries such as scikit-learn, pandas and numpy. Second one is load and prepare data. Load your data into pandas and framework, handling missing values and performing feature scaling as needed. Third one is split the data. Divide your data set into training and testing sets to evaluate the model performance. Fourth one is create the model and instantiate a logistic regression object from the scikit-learn. Okay, the fifth one is train the model. Fit the model to the training data. Use the dot fit method or function on it. The sixth step, make predictions. Use the train model to predict the outcome for a new data using the predict method. Okay, seventh, evaluate the model. Adjusting the model's performance using metrics or as an accuracy, precision, recall and effect one. So there are basically there are 7 steps of logistic regression. First one, import libraries. Second is load and prepare the data. Split the data into dependent and independent. Okay. Fourth one is create the model. Creating logistic object explicit learn. Okay. Fifth one is train and model. Use fit method for training the data. Make prediction. Use predicted to predict predict your data. Evaluate the model. Access the model performing using matrices and accuracy, precision, recall. Um, First one accuracy, we check accuracy, then precision, then recall, and then F1 score. Okay, you will go through this Python program and you know about the logistic regression model in Python, what it does in Python, how is work. Interpreting logistic regression results. After training your logistic model, it's important to interpret the result to gain insight into the model performance and the relationship between variables. There are four key points. Okay, first one is coefficient, second one is p-value, third one is odd ratios. I will make it more visible to you. Okay, first one is coefficient, second one is p-values, third one is odd matrix, and fourth one is confusion matrix. First one is coefficient. So what does coefficient mean? Coefficient represent the weight of each independent variable in determining the outcome. Positive coefficient indicate a positive relationship, while negative coefficient indicate a negative relationship. P-value. A p-value indicate the statistical significance of a coefficient. A low p-value, typically below 0.5, suggests that coefficient is statistically significant and likely to be true predictor of outcome. Okay. Fourth one is odd ratios. Odd ratios provide a measure of how much the prevent change for a independent variable. An odd ratio greater than 1 indicate the increased probability of event, while an odd ratio less than 1 indicate the decreased probability. Confusion matrix. A confusion matrix is a visual representation of data performing showing the number of true positive, true negative, false positive, and false negative values. Okay, this is interpretation of the result of logistic regression. A Poisson regression, modeling count data. The Poisson regression is a statistical model using for analyzing and predicting count data such as number of events occurring within a specific time period or a location. This model assumes that the dependent variable follows a Poisson distribution. Means this model already assumes that the dependent variable is follows the Poisson distribution. Okay, which characterize the probability of observing a certain number of events given by average rate. There are key points. Key assumption: the dependent variable represents could not count data, or meaning it involves the number of occurrence of an event. Distribution of Poisson regression. Okay, the data follows a Poisson distribution where the mean and variance are equal. Purpose: the to predict the expected count of events based on the dependent variables. So the examples of this is predicting the number of car accident in a city based on a factors like traffic density, weather conditions, and road designs. So this is all about assumption in Poisson regression. Okay. So implementing Poisson regression in Python, there are also 6 steps similarly to logistic regression. Python explicit and state models libraries provide tool for building and analyzing Poisson regression models. Let's explore the key points. First one is import libraries. Import the necessary libraries such as state models, .formulas, .ips for Poisson regression, pandas for data manipulation, and numpy for numerical calculations. Second one is load and prepare data. Load your count data into pandas data frame. Ensure the dependent variable represent the number of events and prepare your independent variable as needed. Third one is define the model. Use the state models.formula.api library to specify the model using formula syntax. For example, count space variable, independent space variable 1 plus independent variable 2. Fit the model. Fit the Poisson regression model to your data using the dot fit model. This step estimates the coefficient of the model. Fourth one, prediction. Fourth, make predictions. Use the fitted model to predict the expected count of event for a new data using dot predict value. This is almost similar to the logistic regression, but there are some key points which are changed. Evaluate the model. Evaluate the model performance using metrics such as mean spread error, root mean squared error, or R squared, and plotting residuals and inspecting the model assumptions. So, interpreting Poisson regression results. Interpreting Poisson regression results involving examining the model coefficients and their significance. The significance. The coefficient indicates the impact of each dependent variable on the expected count of events. Coefficients, p-values, goodness of fit, and residual analysis. The coefficient present the change in the expected count of event for a one unit change in the dependent variable. For example, a coefficient of 0.5 for traffic density means that's a number of increase in traffic density is associated with 0.5 increase in expected of car accidents. P values. The P value indicate the statistical significance of the coefficient. Low the P value, typically below the 0.05, suggests that the coefficients are significantly likely to be true predictors of the count events. Goodness of fit. The goodness of fit measure how well the model fit to the data. Metrics like R squared and divines can be used to access the model fits. Residual analysis examine the differences between observed count and predicted count. This can help pattern or outliers that may indicate the misspecification or violation of assumption. This is all about logistic relation and patient regression. Practice consideration. When applying logistic and Poisson regression in Python, remember there are practice consideration: data quality, model selection, overfitting, and model interpretability. Data quality means ensure your data is clean and free of errors, handle missing values appropriately, and consider features scaling or standardizing if needed. Model selection: choose the appropriate model, logistic or Poisson, based on the nature of dependent variable and assumption of model. Overfitting: avoid overfitting model by technique like cross validation or regularization. This ensures the model generalize well to unseen data. Model interpretability: focus on the interpretability, the result in meaningful way. Clearly explain in the model's coefficient and limitation. So this is all about the regression modeling. Thank you for today. We will meet tomorrow.